Welcome to Structural Engineering Online. We are dedicated to provide teaching and learning support through video lectures. Please subscribe to our channel if you have not yet subscribed. In this lecture, we will learn about the stability and determinacy of structures. These two things are very important for structural engineers. First of all, we look for statically determinate structures. When we call a structure as statically determinate, what does it mean? A structure is said to be statically determinate if the unknown forces can be determined by using the equations of static equilibrium. What does it mean? What are the unknown forces? Unknown forces are the reactions at the supports. Right? If you don't know the reactions at the supports, we cannot calculate shear force, we cannot calculate bending moment, we cannot calculate deflection. And what are the equations of static equilibrium? The equations of static equilibrium are sigma fx equal to 0, sigma fy equal to 0, and sigma m equal to 0. These are the three equations of static equilibrium. If our reactions are equal to, if R is equal to E, the number of equations, R is the reaction and E is the number of equations of static equilibrium for that structure, then we say that our structure is statically determinate. That means we can easily calculate the reactions if the number of equations of equilibrium of the same amount are equal. And you know that for a rigid body, the equations are 3. These equations of static equilibrium are 3 for a two-dimensional structure for a rigid body. We will solve some problems also based on this determinacy. Now, to ensure the equilibrium of a structure or its members, it is not only necessary to satisfy the equations of equilibrium, but the members must be properly held or constrained by their supports. It is very important that there should be proper support for that structures. Sometimes you will find that the reactions are equal to the number of equations of equilibrium, but those reactions are all parallel, means our structure is kept on rollers. So if 3 rollers are there, all of them are giving you the vertical reactions, and in that case you know that this structure will not be a stable structure. We will be solving some problems here also. So here we will see what are those conditions for stability of the structure. We must have a stable structure, then and only then it will be useful to us. So first condition for stable structures, number of unknown reactions should not be less than the equations of equilibrium. If you see here in this structure, here we have only 2 roller supports, and this structure is resting on these 2 roller supports. So every roller support will give you the reactions which are just total reactions 2. So 2 reactions, and how many equations for a rigid body? We have 3 equations. So R is less than E. So in such a case, when the reactions are less than the number of equations of equilibrium, we get a structure which is unstable structure. So this is one condition of stable structure, that the number of reactions should not be less than the number of equations of equilibrium. Okay. So here R was equal to 2, but E is equal to 3. Therefore, this structure is unstable. Now, second case, all the reactions should not be parallel. As I just now gave you the example, here roller, here roller, roller. So we have 3 roller supports. Every roller support will give you 1 reaction. So total reactions are 3. R is equal to 3. How many equations? E equal to 3. Just by looking at the number of reactions and number of equations, somebody will say, oh yes, R is equal to E. So this should be determinate. But if you find that this structure is unstable, if there is some slight horizontal force on this structure, the structure will not be able to support the load. So we cannot consider this as a stable structure. Now third condition for stable structure is that all the reactions should not be concurrent. This is another condition. If you see here in this structure, this is some arrangement which may happen in some structures. If all the reactions are passing through one common point, if you see here, this reaction will be perpendicular to this surface here, because these are roller supports, and here also we have this roller support. So these three reactions will meet at one common point. So when these all the forces are meeting at one common point, we call them as concurrent forces, means passing through one common point. So this should also not happen. So these are the three conditions which should not exist in our structure to make them a stable structure. That means the number of reactions should not be less than the number of equations of equilibrium. All reactions should not be parallel, and all reactions should not be concurrent. So these are the three conditions. So now we will solve some questions to determine whether a structure is stable, unstable, statically determinate, or statically indeterminate with the help of these examples which are given below. If you see here in the first example, you will find that the structure is resting on hinge here. This is hinge support. This is giving you two reactions. Roller will give you one reaction. So there are three reactions. So we can say that R is equal to 3. And to check for the stability, we first of all check that the reactions which are 3 in number, these are all not parallel, and reactions are not less than the number of equations of equilibrium, because this rigid body will have how many equations? Equations equal to 3. So 3 reactions and 3 equations. Now according to our definition, if R is equal to 3, R is equal to equations, then we say that the structure is determinate. And also if we see here, the reactions are not parallel, the reactions are not concurrent. So this structure is known as statically determinate and stable. So for stable, we check with this condition, is stable. Why? Because the reactions are not parallel and the reactions are not concurrent. Reactions are not less than the equations of equilibrium. Now we look for its static determinacy, whether it is statically determinate or indeterminate. If we see here, when we say that R is equal to E, so the structure is statically determinate. Okay. Now we come to the second structure. In the second structure, we have a fixed support here. There is one roller support. So roller will give you one reaction. This roller will also give you one reaction. And the fixed support will give you 3 reactions. So again, we can see very well that all the reactions are not parallel. 3 reactions are parallel, but the fourth one, this is horizontal, and the moment, these are not parallel reactions. So we can say that all the reactions are not parallel, all the reactions are not concurrent, and the reactions are not less than the number of equations of equilibrium. So in this case, we have R equal to 1, 2, 3, 4, 5. R equal to 5, and equations equal to, because this is single rigid body, every rigid body will give you 3 equations. So we find that this structure is having reactions more than the equations of equilibrium. Therefore, we can say that this structure is stable but statically indeterminate. And when it is statically indeterminate, we also have to find the degree of static indeterminacy, which we can say that This can be calculated as the degree of static indeterminacy as R minus E. So reactions are 5, equations are 3. So degree of static indeterminacy is equal to 2. So this way we have solved for this second question also. Now we look at the third equation. In the third one, we have these two supports as the fixed supports. And then there are two internal pins. Internal pins means there are three different parts and these parts are connected. We can say it is like this. We have one part here and then there is internal pin which has connected these two like this. Similarly here another one, you will see. So these are connected, these three pieces are connected. So if there are three single pieces, every single piece will give you three equations of equilibrium and every pin will give you two additional reactions. So here we have three reactions, okay, and here we will get two reactions at the pin. Here also we will get two reactions at the pin. So total reactions in this case are equal to 3 plus 3 6, 6 plus 4 equal to 10. And because there are three rigid bodies which are connected by these internal pins, so we can say that the equations are 3 times 3 equal to 9. So R is equal to 10 and E equal to 9. Therefore, it is indeterminate and the degree of static indeterminacy is R minus E, that is 10 minus 9 equal to 1. So this way we have solved for this third question also. Now in the similar way we can solve for this next question where we have a structure which is not a straight line. In all other problems it was just a straight line. Single body, question number second was also having single body, but the third one it was straight line but three individual parts were joined together by internal pin. But here it is not a straight line in a straight line, but it is single piece. There is no joint anywhere. So a single rigid body will give you how many equations? 3 equations of equilibrium. So now at the hinge we will have 2 and the roller will give you 1. Now we can say very clearly that this is stable structure because all the reactions are not parallel, all the reactions are not concurrent, and reactions are not less than the equations of equilibrium because E is equal to 3, R equal to 3. So the structure is stable and statically determinate. With this we come to the end of this lecture. I hope you enjoyed this lecture and it has helped you to get some knowledge about stability and determinacy of structure. If you like this, please click on the button of like and share it with your friends so that they can also get the benefit of this lecture. And please don't forget to subscribe to our channel. Subscription is completely free so that in future whenever we upload any new video lecture you will get the notification. And also please write your comments. If you need some other lectures on different topics, please inform us. Thank you very much.